What if a visitor from another star system showed up and broke every law of physics we thought we knew? On October 29, 2025, that's exactly what happened. The third confirmed interstellar object, 3I Atlas, went completely wild as it rounded the sun, erupting in a way no scientist could explain. It was a cosmic anomaly that challenged our most fundamental models of the universe, forcing a complete rethink of what's possible out in the cosmos. What really happened out there in the sun's glare, and what does it tell us about the mysteries lurking between the stars? Let's delve into it. The alarm. It began with a single jarring spike in the data. On the night of October 28, 2025, the steady stream of information from our solar observatories was shattered. Stereo A's instruments, designed to watch the sun, picked up a sudden massive surge in brightness from 3I Atlas. This automated photometric data is the frontline defense for detecting unexpected events, and this one was a 5 Sigma alert. Within minutes, the same alarming signal appeared in data from the SOHO spacecraft's LASCO coronagraph and the GOES-19 satellite. At the Naval Research Lab, astrophysicist Carl Battams, a real-life expert who manages these projects, was the first to see it. At 1:26 UTC, he flagged the jump in his team's internal chat. The numbers didn't fit any known model. 20 minutes later, halfway across the world, astronomer Quanji Ye at the University of Maryland independently confirmed the break. The object's brightness was now climbing at nearly double the speed it had just days before. With the object lost in the sun's glare for all ground-based telescopes, these space-based assets were our only eyes on the event, and they were sounding a clear, unambiguous alarm that something profound was happening. Breaking models. Imagine you have a rulebook for how comets are supposed to behave, and an object from another star system shows up and sets that book on fire. That was 3I Atlas. As analysts like Ye Quanji looked closer, the data became even more bizarre. The comet's light curve, which tracks its brightness, was steepening at an insane rate, described by the formula R to the -7.5 power. In layman's terms, this means its brightness was increasing exponentially faster than the physics of sublimating ice should allow. It was steeper than any comet from our own Oort cloud, and the rate at which its brightness was doubling was completely unheard of for an object so close to the sun. This violent surge in luminosity defied the basic laws of thermodynamics that govern comets. Every known model for cometary behavior was useless here. They all predicted a smooth, steady ramp-up, not this sudden explosion of light. The global network of astronomers combing through the raw data was stumped, forcing them to question every assumption. The sharp, unexpected break from all predictions was a clear signal that they were dealing with a completely new class of object. Chemical clues. So, what was driving this impossible explosion of light? The answer had to be in its chemical fingerprint. As the alarm bells rang, spectrographs went to work, translating the raw light into its core components. The first clues were classic signs of a comet in distress. Strong C2 swan bands which glow with an unmistakable blue-green signature, and NH2 emissions from ammonia. These signals told astronomers like Quanji Ye that volatile ices, likely frozen for billions of years, were breaking free from the nucleus and vaporizing under the intense solar heat. But the story was deeper than that. The color of the coma, the atmosphere around the nucleus, began to shift dramatically towards blue. This is a hallmark of an object whose light is dominated by glowing gas, not reflected sunlight from dust. In a normal comet outburst, you get a broad reddish tail of dust. Atlas had none. This was a pure, raw chemical event, revealing a composition or physical process, unlike anything seen in comets from our own solar system. The sheer lack of silicate or carbonaceous dust signatures was a glaring omission that pointed to a very alien origin. Ultraviolet surge. The most critical evidence in this cosmic investigation came from a part of the light spectrum we just can't see, the ultraviolet. With 3I Atlas lost to ground-based telescopes in the sun's glare, astronomers turned to the Swift satellite's UV optical telescope. Its detectors picked up a massive surge of OH emission, which, by the way, are hydroxyl radicals. In comet science, OH is the unmistakable smoking gun for water. It forms when the sun's powerful ultraviolet light splits H2O molecules that are escaping the comet's nucleus. The data from Swift was precise and honestly, pretty shocking. As analyzed by planetary scientists like Casey Lease, it showed water production rates soaring to about 5.7 × 10⁻⁻⁶ to the 28th molecules per second. That figure is nearly 40 times higher than the water output measured just 1 month earlier, a truly colossal eruption of vapor. The timing was perfect. This huge surge in water production tracked exactly with the sudden brightening of the comet. This confirmed the outburst was a deep-seated violent eruption driven by the sublimation of vast amounts of water ice, not just a superficial dust event.
Space eyes.
With Earth-based telescopes blinded by the sun's glare, humanity's only view of this extraordinary event came from our robotic eyes in space. The coronagraphs aboard Stereo A, SOHO, and JWST stared into the solar glare and recorded an object that, honestly, defied every visual expectation. A coronagraph is a special instrument that blocks the sun's overwhelming light, creating an artificial eclipse to see faint objects nearby, where there should have been a familiar, fan-shaped plume of dust stretching away from the sun. The images revealed something else entirely. A large, smooth, and elongated coma, about 4 arc minutes across. This glowing envelope was bright, holding steady near magnitude 9, a level that should have produced a spectacular dust display. Yet the data told a different story. Analysts, including those on Carl Badams's team, scoured the pixel-level details, looking for any sign of jets, a faint tail, or any structure that might betray the presence of solid grains. There was nothing, just a massive, featureless cloud of glowing gas. The object was so bright, it risked saturating the sensitive detectors, forcing the team to adjust their analysis techniques on the fly.
Missing dust.
Why was the dust missing? This became the central haunting question for everyone studying 3I Atlas. In our solar system, the physics are simple. When volatile ices like water turn to gas and erupt from a comet's nucleus, that escaping gas drags dust and rock along with it, creating the iconic tail. A spike in gas almost always means a spike in dust. Yet, Atlas was venting colossal amounts of gas directly into space, with little to no solid material joining the outflow. Seasoned observers were baffled. They searched the data for any hint of dust, faint jets, a subtle broadening in the red channels, but nothing materialized. This absence wasn't just a visual curiosity, it threw a wrench into every attempt to model the comet's physical behavior. Without a dust tail, crucial estimates of the nucleus's rotation and surface structure became pure guesswork. This strange behavior suggested something profound about its composition. Perhaps its dust grains were just too large and heavy for the gas to lift. Or maybe the gas was escaping in a diffuse way that couldn't loft any solids at all.
JWST's discovery.
The answer to the mystery of the missing dust actually came from data gathered months earlier. In July of 2025, while 3I Atlas was still cruising towards the sun, the James Webb Space Telescope's NIRSpec instrument took a really close look. Heidi Hammel, a renowned planetary scientist and a key leader for the JWST program, described the results as both a surprise and, honestly, a warning. The surface of Atlas was anything but pristine. The data pointed to a thick crust, somewhere between 15 and 20 meters deep, forged by billions of years of cosmic ray bombardment during its long journey through interstellar space. The chemistry was just, well, bizarre. The carbon dioxide to water ratio was nearly 8:1, which is far beyond what we see in local comets. This was the smoking gun. Lab experiments show this exact chemical signature is created when ices are blasted by high-energy radiation for eons. The pristine material, from its home star system, if it still exists, lies buried deep beneath a shell sculpted by cosmic history. This was not a window into another world's birth, but a diary of its lonely, multi-million-year voyage through the galaxy.
Cosmic armor.
What could build a 20-meter-thick crust on a comet? The answer isn't a star, but the galaxy itself. Dr. Stephanie Malam's team concluded that the crust on 3I Atlas was forged by billions of years of bombardment by galactic cosmic rays during its journey between the stars. These are high-energy particles that relentlessly slam into any object in deep space, fundamentally altering its chemistry. This intense radiation converts simple ices into complex organic molecules, creating a tough, dark, and compacted surface layer. This isn't just a surface tan, it's a deep protective armor. This radiation-processed mantle acts as both a shield and a filter, slowing the escape of gas from the interior. The pristine, volatile ices were still there, but they were buried deep beneath this cosmic shell. The theory is that the sun's heat slowly penetrated this armor, eventually reaching the untouched ices below and triggering a runaway explosive reaction. The surface of Atlas wasn't a window into its birth, but a detailed record of the brutal journey it had endured.
Rival theories.
When data breaks all the rules, incredible new ideas rush in to fill the void. The first major theory, supported by the JWST findings analyzed by experts like Heidi Hamel, is the radiation-processed crust model, but other theories quickly clashed with it. One popular idea among thermal physicists was the carbon dioxide cooling cap model, which argued that a frost layer insulated the comet until solar heat vaporized it, triggering the sudden outburst. A more exotic theory proposed an engineered nucleus, suggesting the object wasn't natural at all, and its activity was switched on abruptly once a certain threshold was crossed, a possibility that made even seasoned astronomers pause. Finally, Dr. Suzanne Falzner, a real astrophysicist who studies planet formation, has theories that could apply here, such as the idea that Atlas is a planetary building block, a planetesimal, with a distinct layered structure that fractured under stress. Each model offered clear, testable predictions about the timing, chemistry and symmetry of the outbursts. Only more data could decide which, if any, was right.
Global sprint.
The bizarre behavior of 3I Atlas created a rare moment of unity and urgency. With the comet diverging so sharply from all known models, astronomers knew that no single team could solve this alone. As Atlas began to move away from the Sun in November 2025, a fleeting window of just a few weeks opened for Earth-based telescopes to observe it again. This triggered an unprecedented global observation sprint. In online forums, astronomers like Carl Battams and Ye Quanji pressed space agencies to release all raw data from Stereo A, SOHO, and GOES-19 immediately. In response, teams around the world coordinated target lists, shared calibration scripts, and posted raw files to public repositories. Radio astronomers listened for non-natural signals, while spectrographers focused on catching any changes in the comet's chemistry as deeper layers were exposed. This collaborative effort was a new model for astronomical discovery, allowing the entire world's scientific community to work together to solve a shared cosmic puzzle. On October 29, 2025, 3I Atlas reached the closest point to our sun and broke all the rules. It brightened at twice the predicted speed, its water vapor outflow jumped by a factor of 40, and it produced a massive, dustless coma. JWST data suggests it's wrapped in a 20-meter-thick crust, hardened by billions of years of interstellar radiation. Yet, the true cause of its violent, dust-free outburst remains an open question. Competing theories abound, but as of now, no consensus exists. We are left with a profound reminder that even with our most advanced instruments, the universe's visitors can still leave us utterly mystified and rewrite our textbooks in real time. With observatories like the Vera Rubin now online, we expect to find many more, making this a puzzle we must solve. What do you think is the true nature of 3I Atlas? Let us know in the comments. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Thanks for watching Stellar Tech.